What? Final. Fine. We'll do it Thursday. All right, here we go. Derivative of arc sine. Derivative of arc sine. So we started this unit talking about inverse functions. For example, we said suppose that y was equal to 2x plus 4. We found the inverse by switching the x's and the y's, right? Remember that? That's what an inverse function is. A for the day, who could tell me what the inverse function of e to the x is? Natural log of x. The inverse function. Now, the derivative of e to the x is e to the x, but the derivative is not the inverse, okay? So you have e to the x, you have natural log of x. Those are inverse functions of each other. Anybody know what the inverse of sine of x is? Arc sine, or sine inverse of x. Arc sine and sine inverse mean the same thing, okay? So the derivative of arc sine is the same thing as the derivative of sine inverse of x. Okay, so what is the derivative? The derivative is 1 over the square root of 1 minus x squared. These are the same things. The derivative of these, same thing is that. Okay, we're going to try again. Arc sine of x is the same thing as sine inverse of x. Those are the same things. So if you were to take arc sine of x and you were to take the derivative of it, you would get 1 over the square root of 1 minus x squared. So since sine inverse of x is the same thing as arc sine, if you take the derivative of it, because it's the same thing, you get that same thing. Whoop. These are the same things. So they produce the same derivative. Better? All right. Okay, arc cosine would be the same thing as the derivative of cosine inverse. Those mean the same thing. What's the derivative? Negative 1 over the square root of 1 minus x squared. Derivative of arctangent. You know what it is? Tangent inverse comes out to be 1 over. Chris has done his homework. 1 over 1 plus x squared. Anybody want to guess cotangent? Arc secant be 1 over that's x roots of x squared minus 1. Anybody want to guess arc cosecant? It's so beautiful outside right now. I mean, it's just awesome. I was hoping for a fire drill today. I mean, no, I'm not. Look at I mean, you guys, you only get this look a couple times a year. And you just, the ice and the frost and snow is just plastered to the trees. And you got the light now coming out and shining on it. You see this just beautiful sparkle. There's little bits of ice and snowflakes flopping around in the air. Oh, a poet, yeah. It's just beautiful. It's just beautiful. Yeah. Yep, you try to take those days in. Try to take those days in. Okay, so let's find the derivative. What rule do you think I use? Chain rule. So on the inside, I have e to the x. On the outside, I have cosine inverse of u. Instead of writing arc cosine, I often like to write cosine inverse. That's the way my mind works. What's the derivative of e to the x? Isn't that awesome? And the derivative of arc cosine is -1 over the root of 1 minus x squared. You do. Fortunately for you, you've become very good at memorizing things because you've taken Western and Gov. Also, I've done my work to prepare you. I've given you a list right on the back of your notes that has all the derivatives right there for you. Your list is now complete, folks. That list of derivatives, you should know them all. So this really is your final exam. Your final exam is you got to be able to take the derivative of anything that you see. And limits. Derivatives and limits. Yep, that's it. All right, so I end up with the following. I'm going to multiply these two together. And so we end up with negative e to the x in the numerator, and the denominator, the root of 1 minus e to the 2x. Piece of cake, upside down. That is just the answer. Riley, thank goodness. We're concerned. Question? I made a little mistake here. That should have been a U. So when you plug the E back in, it's, yeah, sorry about that. Okay. Thank you. All right, so next one, chain rule again. I've got tangent inverse or arctangent of U, and the inside is 4 minus 2x. What's the derivative of 4 minus 2x? -2. What's the derivative of arctangent? I try to make it easy. That is just it. I would like to give you a tiny glimpse into the future, can I? What's the derivative of 3x squared? 6x. Can you tell me what function did you take the derivative of to get 3x squared? Okay, folks, just follow here, because trust me, you can do it. I said, what's the derivative of 3x squared? You told me 6x. So that means you took the derivative of 3x squared to get that. So what would you take the derivative of to get this? X cubed, yeah. Going backwards is a little bit tougher to think about, isn't it? And so I want you to now consider this. You said that the derivative of arctangent of 4 minus 2x was that. Think about taking this and going back to that. That's second semester. Yeah, this is, yep. All right, you try this one on your own. Go. Number 3, you got it. You guys are smart. What do you think? Yeah. Sine of u, arc sine of u. Root of x. Derivative root of x is 1 over 2 roots of x. And derivative of arc sine is 1 over 1 minus u squared. So when we put the square root of x in for u, when you square the square root of x, you just get x. Now also, I want you to understand that you're multiplying these two together. So as I multiply those two together, you can see the 2 roots of x are in the denominator. Now, whether or not you want to multiply that root of x together with the other piece, that's up to you. But I want to make my point earlier that finding the derivative, that's one deal. But to try to go backwards and find out that the antiderivative that we would say of this is that, it's a whole nother ballgame. And when you take Calculus 2 in college, they expect that you'll remember every derivative, every antiderivative, and every limit. That is just something that you knew and you're good at. So, and trust me, you'll get really good at finding antiderivatives. But this one's tough. That one's tough. So, yes. No. Yep. Got it. So if you have, say, the square root of 2 times the square root of 3, we just say that's the square root of 6, right? So you simply just take these two together and multiply it over. That's the property of square roots. You could think of it as like this as well. 2 to the 1/2 times 3 to the 1/2. That's same as 2 times 3 all to the 1/2. So it needs to stay there. Okay. All right, the next one. What rule? Product. Yeah. Product with the chain. I mean, just about everything involves a chain rule now, right? But this one definitely has the product starting. So I've got f prime of x is equal to, I start with the derivative of x, which is just 1 times the natural log of arc cotangent of x. Pretty easy so far. Plus x times, now I need the derivative of natural log of arc cotangent of x. What rule do I use there? I use the chain rule. Thank goodness for the chain rule, right? Like, I mean, talk about an important, powerful rule that we've used. Natural log of u, tangent inverse, no, cotangent inverse of x. What's the derivative of arc cotangent? Yep. What's the derivative of natural log of u? 1 over u. So when I multiply these together, I get a -1 over cotangent inverse of x, or arc cotangent, times 1 plus x squared. Yeah? So times, it's -1 over, I guess I used arc cotangent there, so I'll just write it again. Hi. You can use GG's. Oh, you're so funny. All right. So we got the natural log of arc cotangent of x minus x over arc cotangent of x times 1 plus x squared. And that's it. That's the answer. Is there something you want to do to it? Because I don't see what to do with that. Yeah, so some people have asked the question, how do we know when to stop? Right? So it's kind of like this. I'm teaching algebra, and a student leaves their answer like this. And I say, well, you have to reduce that. And they may say, well, how do I know that? Well, you need to know that each part is divisible by 5, right? So if you look at the problem, you see that combining terms will allow something to cancel, or there's an identity that will take form. Would you leave an answer like x squared minus 1 over x minus 1? No, you'd factor the top, right? So you got to look for factors or things to cancel. And the fact is that they don't in this situation. So, okay, we got 2 more. and then you got time to work. So, and my board is dragging again. Okay, this one looks fun. I like this one. Okay, so I got cosecant inverse of u. I got e to the 3x plus 1. Do you remember the derivative of e to the 3x plus 1? 3e to the 3x plus 1. That's awesome. Due to the chain rule. E to the u, 3x plus 1. Derivative is 3. E to the u, 3e to the 3x plus 1. Boom. Cole, awful quiet today. Yeah. It's okay. It's okay to be tired. The derivative of cosecant inverse. Negative 1 over u roots of u squared minus 1. So I got to multiply this. So it's going to be a negative 3 e to the 3x plus 1 over, what do I put in for u here? E to the 3x plus 1 times the square root of, what happens when I square this guy? 6x plus 2, yep, e to the 6x plus 2 minus 1. Yeah, see the e to the 3x plus 1, one's in the top, one's in the denominator, they're factors, so we go away. Negative 3 over the root of e to the 6x plus 2 minus 1. You are not dumb. Watch. E to the 3x plus 1 quantity squared. If you have a power to a power, what do you do? Multiply. Convinced? Okay, last time I'm going to do this to you, I want you to watch. This is really interesting. If we wanted, we went forward, we took the derivative and we got that. If you were going to take the antiderivative, you would have to anticipate that those would cancel. Like, how do you do that? Oh. And that's why it's so interesting, is that we can take the derivative of any function that we see. We really can in mathematics. But taking the antiderivative, no. There are many functions we don't know the antiderivative of. We have ways of producing excellent estimates, but it's an amazing process. So anyway, it is definitely not guess and check. It is definitely not. Look at Braden's. All right, here we go. Arctangent of x minus the root of 1 plus x squared. What rule? No. We do the chain and the chain. There's going to be two chain rules. It's not, and this is the biggest mistake I think people make. They think of this as arctangent times. You guys, it's got to be, arctangent is no different than like a square root sign. It's an operation. You have to take the square root of something, right? So when you're taking the arctangent of something, so it's not arctangent times, okay? So, cool. I got arctangent of u, and then I got x minus the root of 1 plus x squared. Oh boy. Yep. What's the derivative of arctangent? Okay, so that thing is going to go there. All right. Now I got to do the derivative of that. So I've got, what's the derivative of x? 1. It'll be minus, and so I need the derivative of this guy. So I've got u to the 1/2, 1 plus x squared. Derivative of 1 plus x squared, 2x. Derivative of u to the 1/2, or 2 roots of u. I'm going to multiply these guys together. What happens to the 2's? They cancel, but I do have an x in the numerator, right? So I've got x over square root of 1 plus x squared. So I have 1 over 1 plus the quantity x minus the root of 1 plus x squared. That's the first part, right? Times, oh yes, times 1 minus x over the root of 1 plus x squared. I don't think we should try to find common denominators or anything. I don't think it's really worth our time, do you? No. I mean, it's already written in factored form because we got times here. I think that that's kind of nice in and of itself. Um, yeah, I think we should just let that be. Looks pretty good to me. I got a nice worksheet for you. No packet, because I know you guys don't like packets.